Hello everyone. Routing equipment is offered by many brands, but for example, Huawei was at the origin of 5G technology, which in 2018 supplied more equipment for routing network traffic than other brands. If we talk about current realities, today the emphasis is on cloud services and the Internet of Things, IoT, and the most interesting is the meta-universe, in which the decentralization of services and numerous VR applications require a higher quality channel to participate in virtual events such as rallies, conferences and presentations. Huawei has the NetEngine 8000 family, which includes the entire range of network switches, from high-performance models for telecom operators to edge models, designed to support a guaranteed level of service at individual infrastructure facilities. Let's look at the example of Huawei NetEngine 8000 M1A. This compact router with a fixed configuration has 16 10-gigapoint slots plus 12 1-gigapoint slots and 4 1-gigabase T ports. The total power consumption does not exceed 75 watts. And the noise level during operation ranges from 36 to 45 dB when operating at minimum and maximum loads, respectively. The version for direct current supply comes with two power supplies operating in a 1+1 configuration. The version for power supply from the usual 220-volt AC outlet is equipped with one power supply and non-removable and with passive cooling. Three 40mm fans with automatic adjustment are quite enough to cool the router itself. The design uses Huawei's own processors, a Silicon brand, as well as FPGA manufactured by N-Logic. The Huawei NetEngine 8000 M1A router does not have a web interface, and configuration is performed via the command line. During the initial installation, the operator will need to connect to the device via RS-232 via a special adapter, and after configuring the IP address, it will be possible to enable SSH access and configure users. Since the NetEngine 8000 series is primarily designed to work in high-speed networks, the functionality is minimized. Actually, routing, and everything related to security settings, and firewall is meant to be run on other devices. Therefore, in the simplest case, to start networks, you need to configure OSPF, BFD and enable VRRP IP address routing redundancy if a fault-tolerant configuration is implemented. As for our tests, IPF3 was used for load generation over the TCP protocol in 8 streams, and virtual servers with Intel X550T2 network cards and a 10 gigabit LAN switch were used as clients. Tests show that the router fully utilizes the physical channel speed, both on 1 gigabit and 10 gigabit connections. But as for the technologies that determine the future of wired and wireless networks, first of all, we note SRv6. It is an IPv6-based segment routing technology that supersedes the LDP label allocation and network resource redundancy protocols, RSVP. In this case, a paradigm is implemented in which the routing decision is made based on an ordered set of instructions, segments, received at the entrance to the SR domain. Each router in the SRv6 network has its own SID label, and when receiving an IPv6 packet in its pure form, it encapsulates an SRv6 header containing a stack of labels. Based on these labels, a map of the packet passing through the routing nodes is built, both using OSPF if the label stack does not contain all the nodes through which the packet needs to pass, and without additional help, if all SID labels from point A to point B are entered into the label stack. We can say that SRv6 allows you to pave the path of a packet through the entire segment without prescribing special tunnels. That is, where previously the packet passed through several VLAN and VPN tunnels. Now it is possible to conduct an end-to-end connection. Flexible Ethernet technology is designed to provide guaranteed bandwidth at the OSI model level. The technology divides the physical layer of the physical Ethernet interface into several identical time slots, all of which have the same bandwidth value. Those, in turn, can also be combined, obtaining the total bandwidth of all slices included in this logical interface. Physically, this looks like dividing the total broadcast time interval into many small time slots of a rigidly defined length. With this configuration, a surge in traffic on one of the logical ports does not affect the others, and the total number of slices on one physical port can be increased 3 times compared to the usual QoS method. Finally, Insight Flow Information Telemetry is an in-band data flow measurement solution that implements a hardware detection approach for each packet, so that even minor network traffic failures can be detected in real time. Instead of sending test packets, iFit directly measures the information transmitted in the packets to obtain data on network quality. This approach makes it possible to increase the accuracy of packet loss detection by 1,000 times compared to traditional methods. iFit does not require external sensors. Router service cards can receive key performance indicators of real data streams sequentially with high latency accuracy. iFit allows customers to monitor the network status using lmmz and determine whether the network quality complies with service level agreements (SLAs), as well as promptly adjust services in accordance with the measurement results obtained to improve the performance of end users. You can read more details in text format on our website.